For today's presentation, I'm excited to bring you one from the consumer products world. So without further ado, we'll go ahead and jump right in here. So today's is, stick with me here. This is just a handle from a toilet valve, and this one it had certain things in it that show certain concepts of the software very well. So what you see here is there is a handle that goes here, trip lever, whatever they want to call it. And with this one, we go ahead and reverse engineer this, and I'll explain some of the techniques that make this project a little special. Also, I wanted to continue on and do a little more explanation on alignment while we're at it, because we covered the highlights of alignment last week, but this week we'll go ahead and continue on with some more advanced types of alignments that I wanted to talk about, and another little concept called scan processes that I wanted to bring into the conversation as well. So this part was scanned with a smaller device, a device like this one down here, right here. You see this one? It was scanned with a structured light scanner, and you could have scanned it with these different types of devices like this one or this one or that one or that one or this one or this one right here too. So that one, this one, that one, that one. This one will scan smaller objects as well. It just depends. It depends on your preferences here. But this one, as you know, if you've seen this part before, you know that it's a quite small part, and that is one of the specialties of this one here. So it's nice to be able to just chalk it up and scan it from some different perspectives, and then merge it together from there. So with that, we'll go ahead and we will jump right in. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what DesignX is really quick before we dive into the application. But DesignX is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter DesignX. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right-hand side, whether these are the high-level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this DesignX product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the DesignX portion. So let's go ahead and get started. As usual, we start out with some modern art. And some of the feedback I had from my survey, which we will have that survey spiel at the end of this webinar as well, if you want to give us some feedback. and let us know different topics or things that you might want us to talk about on the webinar. I'm keeping that feedback as and creating to-dos and lists out of it and using it to help fuel the content for this webinar. But a lot of people were like, hey, I want to see more beginning to end. And sometimes beginning to end projects are longer than what we can show on here. So what I'm going to do with some of this is I will show the beginning to end, but cooking showed a little bit where we show the beginning, piece it together a little bit, show different steps, and I'll highlight the important parts of the project without making you watch every click. So with that, we'll go ahead and get started. But this is how we tend to start here, right? Where we come in and I can use a variety of different tools here. And I'll be a little bit more aggressive there. And see that where I can delete the table and then align the scans like we've done in multiple webinars before. But you know, everyone has its own little every one of these projects actually has its own little quirks, and the geometry is different, and there's different aspects of being able to uh, quickly edit this data here. So I'll do this from this angle and this angle like so, and then from these angles. And we already have a lot of that data from the other scans, so doing it like so here. And I have that one little piece that looks a little weird here that's sticking out. What you can do is if you grab the rectangle tool and click on this, you can see it says like 10 scan data 17. So if I click on it, you'll see here if I scroll down, I can highlight and you'll see that it shows which one it is. And then I can come over here and see, I don't know what happened there. You know, some things happen. Things happen with scan data. So you can just, again, I'm a little more aggressive than I really need to be there, but it's going to turn it all back on. And see it there. And we'll make sure to get this last little bit here. Let's just cancel that out. There we go. And some of this stuff here, the biggest thing I always try to do is just make sure it's disconnected. Little flares and flyers. Some of that stuff will get filtered out as we do this. So then we go ahead and we piece it together. So we'll go ahead and do that as well. Local based on pick point. Now, one thing that is interesting is you can say auto guess. Let's just do this today. You know what? We're going to do auto guess. Group 1, group 2, run it, and let's go. Now, it takes it a minute to run, but let's just see what we get. So the auto guess is kind of along the lines of what I thought. I've said this before. It's not gonna give me, and there are some settings here. You could say alignment order and mess with the settings here. But I just figured, hey, let's go. Now there have been times where I have run auto guess and it has pieced everything together and done a phenomenal job. So I just wanted to run that and just see what it would do today. But typically I could hit undo there. This just shows how you can navigate through it though. And I can say, hey, let's do this. And then moving, you have to click on the thing and the moving group, and you'll see the yellowish, orangish color there will allow you to then plug in information. like so. And as usual, you'll notice that I am using a 3D mouse with this, which really, in my opinion, helps. Some people like them, some people don't. It's all up to personal preference there, but I tend to love 3D mice, and I use it all the time. So we'll just scroll out here, and you see I'm clicking different locations there, and then hit OK, and it will move all of those scans from that over there, and then I can come in and turn on this group like that. And I have more data on this side, so you can come over. You can do this right there. And you see that I'm trying to spread out the points across. Get them somewhat. This has a lot of curvature, but I get them somewhat spread out, eyeball them, and then you see parts with lots of curvature like this. It's kind of easy to align them and lock them in. You have to mess it up in order to get it, because there's lots of, I already have lots of overlap. We already see that. I probably scanned it even more than you needed to, so not a big deal there. But you always kind of have more scan data than normal. So now, all aligned, global fine. Sometimes I'll just clear that out and select all again, just to make sure that I have them all selected. Make sure that they're all aligned. Now, for this portion, what I wanted to do is take a second. If you're processing scans all the time, and you're using Design X to do it, because the reason why I say that is there are some scanners that process the scans. They almost force you to do it in their software, right? So those scenarios where you're doing all the processing in here, which a lot of scanners have that ability to scan directly in here, you can do this thing that we call scan processes. And that's what I wanted to talk about today. It's one of these lesser used piece of functionality that I find that people don't use enough. So, in order to use the scan processes, we can come over to Home. We have a link over here, and you can create a scan process from the Scan Process Designer. And what this is basically a script that will run. So this is kind of like visual scripting in a way, but very basic. It's just a kind of intro level here, and you can create a new process, import a process, export the processes. So if you needed to hand them over to other employees, delete them all. I don't recommend doing that. It should be a little more difficult than that. You can duplicate it, run the process, run a batch process, and then I can escape out of here. So if I'll just hit new, and you see you have beginning and end. So what I can do is just drag over a line between scan data, and if I click on it, I can say global fine, use 100% of the data. I always crank everything to 11, so that's why I say max iteration count 11. So crank everything to 11. So after I do crank it to 11, I can say let's merge it, and we've talked about this before. I'm going to say keep those settings. I want to keep the original data. I want to put it on volume merge, crank it to, instead of 11, we'll just drop it down to 10 or 9. So we'll put it on volume merge, almost tight. So we'll set that there. Then we'll come over to decimate, and we'll hit keep. I'm supposed to hit the checkbox up here, so I'm not doing that. I'll show it properly this next time. So I'll also say 1 I'm going to say decimate, no matter what it is, decimate it down to 1.5 million points and crank it to 11. And then you see here, I'm saying every time do it to a static polyface count. And then after that, I'm going to say, let's scroll down here. Let's run a healing wizard on everything. Hit that. After healing wizard, we're going to tell it. You see we have export here too, by the way. It's really neat. And auto surface. This is a popular thing. You can tell it to run all these common settings and then auto surface. So then we'll tell it to run auto segment not on a CAD tessellated mesh. 20 is my default here. And I'm saying it's going to be pretty smooth. So 20, boom, boom, boom. Okay. So here's my script so far. It's going to do another global find. You can't do enough of those, honestly, right? It's going to then merge. It's going to decimate it. It's going to run the healing wizard to get rid of some information, some errors and stuff in the mesh, some bits and pieces like that. And then after it gets done, it's going to run a auto segment to create regions for me automatically. I just figured I'd throw that in there. And then you'll see here, it's called Design X Process 001. So we will just call it Greg's Merge. So now we have Greg's Merge. We get out of that. And then I can come over to Scan Process Designer. I'm going to say, I want to run a scan process. Let's run it. Greg's Merge. Just to double check, I will say, let's run it on everything, 51 scans. And then we will hit the checkbox to let it fly. Now, what it's going to do is, these are all showing here. So while it's calculating, I can hide stuff. So that way, when it finishes, the only thing that'll be on the screen is the final mesh. So it'll just take it a second here to calculate. So now it's done. You see we have a new kind of modern art on the screen here. I'll just turn off my regions here. I got a shortcut on my 3D mouse. So you see here it went and merged everything together and spit out a nice pretty clean mesh with regions. So if there are regions like this that I would like to merge, I can just click on them individually like that. Come over to region and hit merge. This is always going to happen. Like when you create regions with a mesh, there's going to be like curvature that changes rapidly from the scan, that you're going to have separate regions created here and there that you might want to merge in with the rest. Like so. See that? So that's just always going to be a thing where you're tweaking regions and stuff like that. And then if there are any areas that you want to get rid of, clean up, you can do so. As far as, just sometimes it helps just to surround an area of defects and just click it and get rid of it. Like this. This can be a faster way. Just showing some different techniques that I've used in the past to go around the defects and just separate them, because if they're separated, and you got to make sure I separate them all the way here, because then what I'm separating them for is this, where I come in and you got to switch over here, just click on polygons, inverse, and make sure that the things you want to inverse are. So I can hold control and deflood fill some of those things that I actually do want to keep, then hit delete. So you can do it that way. There's also the custom region. I could have done this as well. I've shown this one before, and a lot of times what I'm doing is I'm trying to show things that approach something a different way, because depending on the project, one thing may be better than another. and it might be easier to do something a certain way. So you see that, defeature that. So there we go. Hole filling as usual. If I wanted to hole fill, I select what I want to fill. This mesh, and I can come back and fill these guys. So you can always do all that stuff. Now, the thing that I really want to show primarily is alignment. How would you align this? There's a few different ways, as usual, you could do it. So you could come in and you can say, hey, I got this region here. I can label it a plane right there. And then this cylinder here. So I could create features like we were talking about before. That's a way to do it. Or I can also use sketches. So if I come in here and I just click on that top plane, I could use the edges of these guys to help me index it. So we'll go ahead and click the target is this mesh right here. And we will drop down and we'll create a sketch there. Turn off regions, turn off mesh. So what I could do is come in and say, let's create that circle. If I wanted to index it based on this, I could, I'm just going to show it real quick, even though this isn't the way I'm going to end up doing it, but I could best fit a circle to there, draw a line to it, and a line perpendicular to that. And you see here, I could make that my coordinate system if I wanted to. Get out of here and create that. But another way to do it would be to come in and use these little edges, these things, to index it as well. So if I wanted to window in that and that to give me a direction, I could do that. Now check this out. I'm just going to leave that just like it is. Turn on my mesh. So I have enough right now to create an alignment. So let's come back over, go to interactive alignment. Now, I'm not claiming this is the greatest alignment in the history of the world here, but what I can just do is just show different ways of going about it. So I can come over and let's just turn the mesh off for a second so I could say this is my 0. Now, I think that cylinder is a pretty accurate, accurate feature to use. So what I did is I used the intersection of this and this at that sketch to create a coordinate and lock in the position. Then I constrain this guy. Now for my last one, I can say X. I want to constrain X with this, which I gathered. You notice it's parallel. It's just squaring it up with that. So this is how it's going to be. Now, if I want to flip-flop anything, I can do so. So if, like that, if this is the way I want to model it, I can go ahead and hit OK. And then, of course, my sketch does not come with it, so I'll just hide that real quick. So now we are squared up. And let's turn on the, there we go. So now you can see. It is squared up with these guys, locked to this and the face on that plane. So we have a pretty good alignment. So I wanted to spend extra time on that alignment. And now we'll go ahead and we will just do a save. And I am going to open up the model file and do the rollback thing that we normally do to show the process of how we modeled this. So with that, we'll just jump over here. Dragged it in. All right, so we'll roll back. There's the scanner, the scans. Roll forward. So I made the determination on this guy that we wanted to do this using the boundary fit tool. So just come in to the mesh and just draw. This is basically a 3D sketch here. And just draw the curve network on the surface however you want to draw it. Make sure there's square patches if possible. After we draw this whole network out, which we've covered on here before, we'll do more of it in a future webinar again, where we draw one out. And then we come in and say, now that we've drawn that out, do a fit. And we will turn this off. So look at that. That's a beautiful surface that it extracts from that surface there. And then what we did is we extended that, because you see here we drew it where it was trimmed back, and then after we fit the surface, now we extended it. If you have nice clean surfaces, you will have a nice easy extend. Now I could also just extend it by offsetting a plane, convert entities, and create a lofted surface between the edge of that and this, but we just did an extend. Now, one thing that happened is, look at here. We extended it, and because it was coincident here, these didn't quite extend right. So rather than go around and around tweaking it, you could fix that. The quicker way would be, let's just draw a 3D sketch, split that face, delete that face, and do a fill face, and then sew it in with the rest. Nobody ever knows the difference. So we went ahead and just patched that little area. Now I show that. I left it and showed it because there are times where you have to, when you're surfacing a model and there's some just areas where a lot of stuff's coming together and it is really difficult to get it to piece it together, you can use this same technique, right? If I just come in, I'm just going to use the same technique right now. I'm going to draw just right here on the surface. Hopefully I will draw. Hopefully, there we go. And you see, I went ahead and created that. I'm just going to do it live here right now and say, hey, let's go ahead and split the face. So the tool entity is this sketch. The target entity is this. There we go. Let's hide my sketch. So you see here, I split that and made it its own face. And then I could come over here and I can say delete a face. And then I could come over and just draw this. And I can add tangency and stuff to it as well, but we're just going quick here. And then I can say fill face here, here. And then sometimes this happens where the normal direction is flippity floppity. So I'll just come over here and flip it around and then sew it in. Like so. So there we go. We just redid that same exact thing there. Now, again, for this project, this was just a quicker way of, rather than trying to troubleshoot and figure out what was going on, I'm just going to keep moving on and see what happens here. Oh yeah, let's go ahead and sew it together here. Did I sew it? I thought I did. So. There we go. So now everything is one solid surface. Now let's just keep on moving. We One way that sometimes I create a down and dirty quick plane is I will just select a surface, draw a square, and then do a fill surface on the square sketch. It creates a surface plane. And then you could also just do it from the side, draw a line, and extrude it to create a surface plane. Whole host of ways of doing that. And then a lesser used tool that people forget about is the solidify. So if I have multiple surfaces, this is only two, but if I had like 10 surfaces that come together, and if all the surfaces intersect in a way that they create a bounded solid, you can say, select both of those surfaces, create a solid out of it. So that's what we did here. And then from there, we chose to shell it to get the inside to make it a nice consistent internal shape. And then from here, it is all downhill. We extrude that piece. We create the side. We then pattern it about an axis. We Boolean it together. So now these are all one piece. Now here's a little trick. So these two solids are still separate. This right here and this right there. And I want to trim them to each other. One way to do it is we create a surface offset and just offset it in. Offset that surface in the body. So you see right there by 1 millimeter. And then use that to cut. Then Boolean that with the outer shape. So a little technique there. You could do it a whole bunch of different ways. It doesn't even have to be like an offset surface like that. Like you can just trim it in a bunch of different fashions there. But that is the rollback of how this was modeled here. So today, again, we focused on scan processes and creating a script to merge them together. Reinforce the alignment techniques of how to align a part when sometimes it's not readily apparent how to align a part like this. And then spending extra time going through some techniques that were used, the boundary fit surfacing and solidify. Don't forget about that tool in here because it's very powerful to create solids. So with that, let's go ahead and jump back over to the PowerPoint. I hope everyone has been enjoying the RE Lab webinar. And I'm always striving to make it better and gather input from a variety of sources. And I had the idea to create a survey and put out a survey just asking for feedback. Mainly the feedback is just to gather data points on the topics, the applications, and if there are any other ideas of applications that people might like us to focus on, and just kind of get the pulse of what you guys like to see, what you like to hear. So this is a very open forum. It asks for some feedback and suggestions, and we'll go through those and implement those. So if you have any proposed topics or things that you might want to learn about Design X, then go ahead and scan this QR code. It takes you straight to a form, and we will take that and implement it. as I stated before, Geomagic Design X Pro is part of a complete lineup of software that has 3 tiers of Go, Plus, and Pro. And again, the differentiators are that Pro has all the tools built in. Plus has plugins and basic modeling tools. And Go primarily is focused on importing data. It has no plugins built in, but it brings in data from POI, OBJ, STL, all those different import formats. We have a huge library of formats that we bring in, more than almost anybody out in the market, and allows you to extract basic model information, send it over to CAD. So Go, extract basic model information, plus add plugins, add more modeling tools. Pro, you get everything. And you have the ability to upgrade from one to the other by trading in Go, trading in Plus to get Pro. So it's a great ecosystem, a great product lineup. But we wanted to make sure that we point out that Pro is part of this lineup and there are other options available.